Chapter 9. Chapter 9 is going to cover what's called the polar coordinate system. Now, my goal for you guys to be able to do for 9.1 is to be able to just to plot points. So nothing fancy, I just want you guys to be able to plot points. Before we start plotting points in the polar coordinate system, I sort of want to explain the difference. Now, the system that we've always used was the rectangular coordinate system, which means that if I give you a coordinate point, such as x comma y, in order to plot a coordinate point in the rectangular system, we always went left or right, x units, and then we went up or down, y units. This was the system that we've always used. However, I want to introduce to you guys what's called the polar coordinate system. Now, the coordinate points for a polar coordinate system, instead of x comma y, is going to be r comma theta. However, before we do that though, I want to indicate a couple of major parts of the polar coordinate system. First of all, the center here, the center is what's called the pole. Think of the North Pole or the South Pole on a globe. The pole is always the center if you look at a globe from the top. Now, the line that goes from the pole all the way to the right, this is what's called the polar axis. So your pole is the center, the polar axis is the line that goes from the center outwards. Now, any point that's on the polar coordinate system is going to have two values. It's going to have r and it's going to have theta. R is the distance that this point is from the pole. Theta is the angle that that point creates with the polar axis. So r is the distance from the pole to the point. Theta is the measurement of the angle that that point creates with the polar axis. Now, with the polar coordinate system though, there's a couple of ways you could plot points. So let's look at a couple of examples. So I'm giving you this polar coordinate system. Now, notice your pole is right in the middle. Notice the polar axis goes all the way to the right. And I want you to notice also that we have all of these angle measurements going counterclockwise. A couple of things I want you guys to understand. Positive angles go counterclockwise. Negative angles are going to go clockwise. All right, so let's look at these points. Point A says, point A is going to be at the point 2 comma 45 degrees. So 2 is our R value, 45 is our theta value. Now what that means is 2 represents the distance this point is from the pole. 45 degrees represents the angle that that point creates with the polar axis. So something I like to do is I like to go left, or I'd like to go right first to get my R value. So what I'm going to do is I'm going to go to 2, which is my R value, and then I'm going to go around to 45 degrees. So we're going to go R equals 2, theta equals 45. This is point A. So point A is at 2 comma 45 degrees. So there's point A. Now, point B is going to be a little bit different for several reasons. One, your R value is going to be negative, and your theta here is in radians. So to make life easy, what I like to do is I always like to change the radians into degree measurements. So quick refresher, if you want to change radians to degrees, all you have to do is take the radians and multiply by 180 over pi. That'll change the radians to degrees. So if I take 2 pi over 3 and multiply by 180 over pi, what that's going to do is that's going to change this radian measurement into 120 degrees. It's just going to make life a lot easier to graph. Now, the next thing I have to be careful is the fact that my R here is negative. So what I need to do is I need to first take a look at positive 1.5 comma 120. Now positive 1.5 comma 120 is going to be 1.5, so between the 1 and the 2, and I'm going to go all the way over around until I get to the 120 mark. So here is, I'm going to put a little dot here. This would normally be positive 1.5 comma 120. Now the problem is though is I don't want 1.5 comma 120. I want negative 1.5 comma 120. So instead of going to positive 1.5 120, what this negative sign does is it forces me to jump to the other side of my pole. So imagine this line that connects 120 all the way across. So instead of going to positive 1.5, 120, this negative sign right here is going to force me to jump to the other side of the pole. So in fact, negative 1.5, 120 would be on this side. It should have been over here if it was positive. If R was positive, we'd be at positive 1.5 here. But because of the negative, it forces us to jump to the other side of the pole. So here is point B, which is negative 1.5 comma 120 degrees. So you need to be very careful. Anytime there's a negative in front of R, you go to where the positive R would have been, and then you jump to the other side of the pole. All right? Point C. Point C is a positive R, so that's good, so we don't have to jump around the poles or anything. However, our angle is negative. So what that means is I'm going to need to start counting my angle measurements going clockwise. So this first angle, instead of 345, it's going to be a negative 15 degrees, and 330 is going to be a negative 30 degrees. Because notice, each slice is 15. So positive 15, positive 30, positive 45. Negative 15, negative 30, negative 45, so on and so forth. So 3, negative 30, which would mean I would go out to 3 and then go down to the negative 30 mark. So C is actually right here. It's kind of hard to see because I wrote over it, but it's okay. So C is at positive 3, negative 30. So there's point C. All right, last one, point D. Point D is going to be difficult for a couple of reasons. One, we're going to need to change that radian measurement into a degree measurement. So negative pi over 2 times 180 over pi. That gives me negative 90 degrees. So point D is negative 1 comma negative 90 degrees. Now, not only is it going to be a negative angle, but because my R is negative, it means I'm going to need to jump to the other side of my pole. So let's go to where positive 1 comma negative 90 is first. Let's figure out where 1 negative 90 would be. So here's 1, and negative 90 means I go clockwise. So 1 negative 90, because here's negative 90 here. So we got 1 negative 90. Now this is where 1 negative 90 would normally be. But because we're looking at a negative 1, I'm going to jump to the other side of my pole. So here is 1 negative 90. Here is negative 1 negative 90. So there is point D.